Okay, so we're going to take a look at selective precipitation in the last video of lesson 3.3. So we have a solution that contains calcium and lead ions, both 2+, and both are at the same molarity. So these are the same. And then if we add solid sodium sulfate, this is a source of SO4 2-. So it's a source of sulfate. We don't care at all about the sodium, just the sulfate. That sodium is going to be a spectator ion anyway. Is slowly added to the solution, which precipitates first. So we are looking at if we took this sulfate and we added it to a solution of calcium and lead, are we going to get calcium sulfate or lead sulfate first? So one thing that we need to know is a precipitate forms. A precipitate. Looks like appointment. A precipitate forms when Q equals KSP. So that means when you finally hit the KSP, you're going to start getting a precipitate forming. Okay, so part A. First we need to determine how much sulfate, how much of this stuff we need to form each individual precipitate. So determine how much sulfate is needed to form each precipitate. Okay, so the first one is going to be calcium sulfate, so CaSO4. And again, we want Q to be equal to KSP here. So let's go ahead and write our, figure out what our KSP equation is. So if we had calcium sulfate, we know that calcium 2+ is this ion, and then SO4 2-, that's our negative ion, and that's going to be equal to the KSP. Here it's telling us the KSP for calcium sulfate and lead sulfate are 6.1 times 10 to the negative 5 and 1.3 times 10 to the negative 8. These are respectively, so calcium sulfate is 6.1 times 10 to the negative 5. So plugging in these numbers here, so the calcium concentration, that's at 0.1 molar, 0.01 molar. And the sulfate, well, we don't know. We're trying to figure out what we're trying to figure out how much sulfate we need to add, so that's our X. Equals 6.1 times 10 to the negative 5 equals, and so if you plug this into your calculator, you should get 6.1 times 10 to the negative 3 molar. So that's the concentration of sulfate needed to precipitate calcium sulfate. That's how much you would need. Once you hit this concentration of sulfate in solution, you would start getting calcium sulfate precipitate on the bottom of the beaker. Now we're going to do the same thing with lead, and we're going to compare. So I would like you to go ahead and pause the video. You're going to do the same thing. Find the X, or find how much sulfate is going to be needed to start precipitating your lead sulfate. So for lead sulfate, we're going to approach this much the same way. So PbSO4, going to go ahead and write our equations here. So your lead, Pb 2+ times SO4 2-. And here our KSP is 1.3 times 10 to the negative 8. So our lead we saw is the same concentration as our calcium up above. Plugging this into your calculator, you'll see that you get 1.3 times 10 to the negative 6 molar sulfate is needed to precipitate PbSO4. So that means if you're adding sulfate here little by little, slowly to the solution, the one that takes less is the one you're going to see first. So which one takes less? So it turns out that the lead sulfate actually takes less sulfate in solution until you first start seeing a precipitate. So that means because lead sulfate requires less sulfate, it will precipitate first. It will precipitate first. Okay, so that was our very first part of our problem up here. Now we have a second part. What is the concentration of the first ion that precipitates? So what is the concentration of lead sulfate, because that's the first ion that precipitates, when the second salt begins to precipitate? So let's rephrase that. Part B. What is the concentration of lead when, let's put quotes around this, when calcium sulfate precipitates? So sometimes it's useful to think about these questions and put it in terms that are more understandable before you start to tackle them. So this is really what this is saying. So we know that when calcium sulfate precipitates, we know that the sulfate concentration has to be 6.1 times 10 to the negative 3 molar. So really what we're asking is, what is the concentration of lead when the concentration of sulfate equals 6.1 times 10 to the negative 3 molar? Because that's when calcium sulfate precipitates, right? So calcium sulfate doesn't precipitate until your sulfate concentration is 6.1 times 10 to the negative 3. So what's the lead concentration when that happens, when your sulfate concentration is 6.1 times 10 to the negative 3? Well, to do that, the only thing you need to do is find the lead concentration with your KSP equation here. So for PbSO4, for lead sulfate, we know that KSP equals lead, so Pb2 plus times sulfate. These are in a 1-to-1 ratio, just like we've been writing before. We know the KSP. We're trying to find the lead concentration. We know the sulfate concentration. So our KSP here is equal to 1.3 times 10 to the negative 8. We know that because we were given that in our original equation here for our lead sulfate, is equal to the lead concentration times your sulfate, which we have decided here, or which we figured out above, was 6.1 times 10 to the negative 3 molar. And plugging all of this into your calculator, you get that the concentration of lead equals 2.1 times 10 to the negative 6 molar. So that means when your calcium sulfate starts to precipitate, your lead concentration, your lead concentration is going to be 2.1 times 10 to the negative 6 molar at that same exact time. So since this was a problem that required lots and lots of steps and lots of rephrasing, I'd like you to please cover this work up with a separate sheet of paper. So this is a really good study tactic. Cover this up with a separate sheet of paper and don't peek at it. And try to work the problem, the whole problem, just like we did the same problem, beginning to end. See if you can get the very, very last answer here for lead. Just because there are so many steps here, that's a really great study tool. Alright guys, that is it for everything we have on equilibrium. So thanks for watching.